Hello everyone, welcome to the second video on using the Multistory Builder functionality in SRAM 2023. In the previous video we looked at creating some different grids. In this example we're working on the creation of a building that has a multi-story tower with the core in the center. The tower and core are reinforced concrete, and it will be adjacent to a podium structure comprised of a composite steel structure. We're now going to look at how we can use the Multistory Builder functionality to create this type of geometry by laying out our floor plans and creating vertical stacks of stories that all relate to one another and can be easily adjusted. So I'm going to continue using this base grids folder that we see here. And I'm going to actually expand on the floor plan tool. I'm going to right click on this floor plan tool, and the capabilities of this tool have really expanded in this release. Here we can specify a number of different floor definitions. So I'm going to start at the base, and I'm going to say here that I can specify the floor top, which I'll assume is the foundation. I'll give it a slab thickness, which I'm going to use of 250 millimeters. And this will represent the base of my structure. I can then left click on this folder, or this row, and click copy above. And now I have a story above that. And I'm going to set this to be floor top of slab, and we're just going to think about our our core and our tower for now. And so I'm going to set up basically floor plans to help facilitate that modeling. I'm going to say that this floor for the bottom is 5 meters high, and I'm going to toggle on this as a level as a floor option, which will allow me to basically treat not only the slab, but the columns and beams that are underneath that as a single floor. And I'm going to continue copying this up, so say copy above. Here we can see that it's basically replicated the same data, so we have another 5 meter spacing floor, which will be at a floor level of 10. Now we could have simply just entered a different floor level, like 11, and the floor spacing will update accordingly. And keep everything nice and even for now. And what I want to do is I want to make this floor basically the same as floor number 2, not only in the floor definitions, but in the geometry that we're going to create, in the loading and so on. So I'm going to set up a same as floor ID relationship between floor number 2 and floor number 3. And I'm going to say that floor 2 is the master floor for the floors above it. So I'm going to say that floor number 3 is looking at floor number 2 for directions on how the geometry is laid out. And just for the sake of my own benefit, I'll just rename this floor as 2M, just to help me denote which one is the master. And I'll continue copying this up a few more levels. And we get to the top here, and I'm going to say this is floor number 6 is where my podium structure is going to finish off. And above that, we're going to have a different floor spacing of 4 meters. And I'm going to keep pointing at floor number 2 as the master floor for now. So keep going, floor above, and I'm just going to keep going until I have my total of 24 floors. And you can see the overall height of 96 meters. And right now, all the floor tops are designated as slab. This helps with not only rendering, but also transmitting data between BIM software. It helps you denote the cardinal point offsets and so on for your slabs, for your members, and whatnot. So the reason I'm doing all this is this helps define the vertical stack of geometry that we're going to create, but we still need to define the geometry in a plan view. And our base grids will help with that, and so will the floor definitions that we've created. So let me select the row with my master floor, and click on this button that says New Generate 2D View. So left click, and now I have two side-by-side views using what we call the multi-view interface in SRAM. I'm going to just make sure that I can position them both so I can see everything. And what I want to do first is lay out the geometry for my core wall. So right now I'm looking in the right-hand view. I just left-clicked on the view to activate it. And I want to actually switch to a different grid. I don't need to see everything in here. I just want to look at the core base grid. So here I can see the base grid that's showing here. I can also turn on the dimensions, which might help me with my geometry layout. And because I am in the plan view and I'm looking at a base grid, here I can use the panel element tool and I can start laying out the geometry for my panel. So first of all, it helps that we have some material properties defined, which I'm using the default materials, and I'm going to select a concrete material type. And I'm going to define some link beams. So I have a concrete beam section size that's going to represent my link beam. We see here within the panel tool, we actually have patterns because we are looking at the plan view and we have a base grid selected. It will activate this patterns option where I can select the wall panel directly from this option. And I can even choose, now that I have a wall panel, to create my walls as quadrilateral shell elements rather than panels which can be meshed. And this might be useful if we don't need as fine of a mesh for our panels in our walls versus our slabs. It can just help make it a little bit more efficient that way. And S-Frame will automatically generate rigid body constraints to connect the joints within our slab to the actual joints in our walls. I'm then going to give it a thickness, which I'll say is 300 millimeters, and I'm going to click OK. And I'm just going to left click here to draw in my walls. And you can see here on the left hand side, we're getting a preview of effectively what our walls will look like. I've turned on hidden surface removal just so we can actually get a little bit more popping view of what it looks like. And now I want to define the wall with the link beam. So I'm going to change the pattern type from a wall panel to wall plus link beams. And when I do this, I have a few more parameters. First of all, the beam span, which if we look at our grid here, we want it to be 3 meters. And the lateral offset from where the start point of our wall is to the start point of our beam is going to be 3.5 meters. And then I just left click to draw this in. And we can see the same thing appearing on the other side of the screen. And we do notice here that we have these joints where this this type of geometry is starting to be growing. So I'm just going to now focus on the creation of our tower geometry. And I do have columns that are going to be in line throughout the entire height of the structure. So I'm going to continue with that, but I'm going to switch the grids from the core base grid to the tower base grid. And you can see I still have my geometry of my wall here. And this time, rather than using the panel element tool, I'm going to use the member type tool, or member definition tool rather. And when I'm working within the panel, the plan view, with my base grid selected, I have the option under the member tool to select from different member types, either a column or a beam. And the beam is by default released, but obviously we can control that. And the columns here are going to be sized according to the stories that we've defined. So we have our first couple floors at a different height than the floors above that. And it will automatically recognize that and accommodate that. So I'm going to use the section property tool and change to the concrete column section. I'm still using the concrete material that I have. And all I need to do now is just draw my columns. And it's quite easy to do if we have a grid laid out already. In this case here, I'm just going to left click and drag with the member definition tool selected. And you can see here, all the grid lines that I left clicked and dragged around will now have their columns created on. And do the same thing in the other directions, just to help me lay out this geometry. And I'll draw one in here as well. And we're going to use this to form the basis of our tower. Now obviously our tower is going to have slabs, which we'll get to later on. But the slabs will change as we go through the story heights, so I am going to modify my floor definitions before I get to that point. And that's something that we can do right now. So I can go to the floor plan tool, and now that I've created all this geometry, it's all set in place. But at this point here, I might want to consider changing the relationship between floor number 2 and some of the upper floors. I'm going to designate floor 6 as my other master floor, so I'm going to call this 6M. And to make it a master floor, we want to make sure that it's not referencing another floor for its inspiration for how the geometry is laid out. So I'm going to change this from same as floor ID 2 to 0 to just clear any reference of a master floor. And what I'll do for the floors above is change this floor number 2 reference to floor number 6. So I'm just going to enter floor number 6 for all the stories above. So now, floors 7 through 24 are looking for floor number 6 for instructions for how to lay out the geometry. The existing geometry won't be affected, but we are now able to start defining additional geometry. Now I'm going to continue on working with this tower grid. And what I want to do now is actually lay out some additional geometry for this tower. So I'm going to define within this tower some panels. And these panels will represent the floors. So I'm going to use the patterns option here and change it from a wall plus link beams panel to the floor panel option. And you'll notice here that the type is set to shell mixed mesh. And this option allows me to generate shell elements which can be created down the line. I'm also going to change the thickness from 300 to 250 millimeters. And I'm going to start drawing the geometry here. So I'm just going to assume for these earlier floors, the lower floors, that the slab basically ends at the location of the columns. So I'll just simply left click the extents of these columns and trace out the perimeter. And I'm also going to change here around the core wall. I'm going to have a hole panel to represent the void in the concrete in that area. So I've got this geometry defined now, and the earlier floors of our tower are starting to come together. Now let's look at the upper floors. So I can change using this floor plan tool. I'm going to switch to floor number 6, and I'm going to generate a 2D view for floor number 6. So say, let's generate a 2D view. And let us now look at the geometry at floor number 6, which has already been defined for us. But now we want to define the slabs for floor number 6 and above as well. So I've just expanded this view to allow me to see things a little bit more clearly. And I'm going to use the panel element tool. And with the panel element tool here, I still have the floor panel selected. And conveniently, the thickness is still set to 250 millimeters. But something that I haven't gotten into yet, aside from the type that I want to change, which I'll set back to shell mixed mesh since it was originally a hole panel, something that I haven't talked about is the slab offset. So being able to generate a slab offset to represent some overhangs, maybe we have a balcony under structure, something like that, this will certainly come in handy for drawing this type of geometry. So I'm going to say that we're going to go with a 1 meter slab overhang or offset, and I'll click OK. And I'm going to start my slab here in the corner, and I'm going to left click, and the next point that I'm going to click, you'll notice here that we get this offset from the points that we clicked, a 1 meter offset. And I'm going to change the slab offset for the next segment to 2.5 meters. I'll left click this point, and you can see a 2.5 meter offset has appeared. And then I'm going to change it back to 1 meter for the next segment to here, and we can see what that's looking like. So essentially what it's doing is it's allowing us to specify an offset for the next segment of panel that we want to create. So this next segment, again, I want to have a 2.5 meter offset to here, then go back to 1 meter to here, go around the corner, and I'm going to keep that all 1 meter. And notice that it is accommodating that corner and maintaining that 1 meter offset. Do the same thing over here. 2.5 meters for this next segment. Back down to 1 meter. And then finally back up to 2.5 meters before our last ramp down to 1 meter. And I'm going to close it off on this final joint here. And we've generated this slab with these offsets for us without having to create any additional changes to our grid. Now I do want to go in and also modify the area in the core. For this, I don't want to have this offset, so I'm going to change the slab offset to 0 meters again. And just left click to draw this in, as we can see here. So we've got this represented, and these will be propagated throughout the height of our structure where our tower does exist. Again, we're looking at floor number 6, which is the master floor for floors 7 through 24. So again, these changes will take effect there. The final change that I do want to make is the creation of some cladding elements. And this will help to allow me to insert line loads that will connect to my mesh to represent the weight of our cladding. And I'm going to do that using the member definition tool. And rather than using the columns member type, I'm going to change it to beams. And we're going to change the material as well. So I'm going to use an aluminum material, and I've defined a section for my cladding elements, which is section number 6. And I'm going to draw that basically on the edges of my slabs. So I'm going to start here and cut through my Sundex, because I don't want those to have cladding on them. Covering them, I guess you could say. And I'll just continue this on, right-clicking to basically extend the member selection or definition. And now I've got the cladding members defined throughout this area. That's not something I've done on the earlier floors, so I can actually go back to the window menu here, and let me go to floor plan 2. And I can see floor plan 2 at elevation 5 is referenced here, so I know exactly which one it is. And I'm going to define something very similar using all the same properties. You'll notice that those are active. And just left click to draw those in. Now if I switch to the geometry view, and maybe I'll zoom out, I can get an idea for what this is starting to look like. We can see here that we have our core wall extending throughout the entire height of the structure. Our first few stories are slightly different than the ones above them. We don't have the slab offset or the Sundex, so we are able to maintain those differences with that master floor relationship. Now the final step that I want to complete is actually looking at the definition of my podium structure. So I'm going to go back to this floor plan 2 at elevation 5, as this will help me lay out the geometry for my podium. This is where my master floor is for the lower stories. And I'm going to change the grid type from the tower grid to the podium grid. You'll notice it extends off the end. And we're starting to see some repetition in the tools that we're using. We're going to have a composite steel structure representing our podium. And to do this, I'm going to use the member definition tool to lay out my columns. So I'm going to change the member type to columns. I'll change the section type to this Y-plan shape. And I'm going to use a steel material as well. And it's just a matter of essentially laying out the column geometry. And then I'm going to have some beams as well. So that's not something we saw as much of in the tower structure since we have flat slabs. But I'm going to use the beams and basically help use the beams in a girder beam, infill beam setup to support my composite steel deck. Here I'm going to change the section size, so I'm going to go with this W410 by 54 section, and we're going to have our girders essentially running in this direction. And we're going to have these girders connecting to the slab and the column on the concrete tower. And in the other direction, I'm going to actually change section size, so I'm going to go with a smaller section size and just left click and drag around the columns that I want to connect with these types of beams. I'm not going to have a beam running along this edge, however. But what I do want to add is some infill beams to help support the composite steel structure. So these are all at 10 meter spacing, these beams. And I want to add some infill beams at 2.5 meter spacing. And to do this, I'm going to use the Generate Infill Beams tool. I can choose which direction I'd like this infill beam to be created in. I'm going to say they're going to go in the X direction because I don't want a bunch of connections to that concrete slab. I want them to basically be spanning parallel to this edge of the slab. I'm going to have it equal spacing, and I'm going to have 3 beams per span, and it's just a matter of me left clicking to add this in. And I'm going to jump ahead to the point where I've created all of these because it does take a second or two to add them, and I have a few bands to create these, so we'll jump ahead. And here we can see that we've got the geometry defined now. What I want to do with this is I want to use this as basically area load members to represent not only the members which will be supporting area loads, but also the members that will be composite members or composite beams for my composite steel deck system. And to do that, I'm just going to use the area load members folder. When I left click on this folder, you can see that it's currently empty. All these elements are grayed out. But I'm going to left click on the selection tool and just select my beams on that side of the structure and add this to the open group. I'll go back to my structure dialog. And what I can do next is I can say, well, you know, I want to define a panel to represent this deck. So I'm going to use the panel element tool again. And with this panel element tool selected here, I obviously don't want to continue using the whole panel type. I'm actually going to change this to the area load only panel type. So with this area load only panel selected, I can use this to facilitate the definition or the directions which my loads will span to the area load members, but also telling S-frame which members are going to be composite steel beam members versus other types of conventional steel members. I can also set up a slab offset. So in this case here, I'll go with a 0.3 meter or 1 foot offset. I'm just going to zoom in here to help me with the definition. I'll start by left clicking this point to draw it in. And finally finish it at the bottom. And we can see here that we created this purple panel to represent our steel decking. And with this steel decking created, we can then go to the span direction tool, and I can tell S-frame to have this member or the area load spanning in the short direction, in the one-way direction rather, in a long direction, or I can have a two-way spanning depending on what my requirements are. This will be useful. It also dictates the direction of our decking. So here I'm going to go with a short one-way span, and we can see here when we apply that what that looks like. It's basically shedding the loads to each of these members here. Now there are a couple other modifications we can make. For example, I may want to decide, now that I've got my tower and my podium defined, I'm looking here and I see that the roof structure actually is not representative of my expectations. So I can go into the floor plan tool and I can say, well, I don't want this floor 24, my roof, to be the same as floor number 6. I don't have a hole in the slab, for example. I might have different loading that I want to represent later on. So I'm going to make this one here same as floor ID 0, so it's no longer looking at other floors for instructions. And I'll give it the name roof. I can then click on the generate 2D view while I have this row selected. And it's going to generate a view of this particular floor. I might want to change my grid so that I can see the tower grid lining up with this. And what I'll do is I'm actually going to shrink the elements for visual checks. And I'm going to unselect just this larger panel here to allow me to delete this whole panel. So now once I've done that, I can just select everything again, and you can see the whole panel is no longer present. This allows me to make additional modifications to this floor. For example, I might want to have, when I mesh this, a different area load, for example, or pressure load on certain parts of the structure, the floor system than the other. That, for example, I have snow loads that might be different on different parts of the structure. I'm not going to have those on the interior floors, but I will on the roof floor. So that's something that I'll have to consider. And that's why I made this one different. If I go back to my geometry window, a few other modifications we can make. Aside from all the other tools that we've used to generate the geometry, like the sections tool and so on, I can go to the floor plan tool and I can say, I put a lot of effort into generating these floors. Let me generate folders to help me organize this data. So I'll click on this generate folders button, and we can see here it's generated the story folders for us. So I can look at story number 1 or story number 4. Maybe I'll just switch views so I don't have all that floor IDs, and it's going to show me all the data relevant to that particular floor. And it's great for organizing and modifying data that you don't want to go in and affect other properties on other floors. So in the next few videos, we're going to continue on with this process. We're going to look at generating geometry and also generating elevation views, in that we can use that for creating bracing and so on. And we'll look at some editing controls that we have now that the structure is already created.